Welcome back. If you are here for the first time, please like, follow, subscribe, and share the video. In today's lesson, we are going to look at motion, one of the most basic concepts in physics. Everything around us, cars, people, animal, air, even the earth, can be in motion. Understanding this will help us to know how objects move and why they behave the way they do. Definition of motion. Motion is defined as the change in position of an object with time relative to a reference point. A change in position of an object with time. You can simply put that motion is defined as the change in position of an object with time. When an object changes its position with time, it means that that object is in motion. Now, any object that does not change its position with time is said to be at rest. It means that that object is not in motion. So we are going to look at types of motion. We have four types of motion. Types of motion. Types of motion. The first one is known as translational motion, and the second one is oscillatory, or you call it vibrational motion. The next one, number 3, is rotational motion. Then number 4, we have random motion. Now let's look at number 1, types of motion. The first one, known as translational motion. This is the change of position of an object. When object moves from one place to another, that object is said to be in a word translational motion. And in translational motion, we have two types. We have what is known as rectilinear motion, and we also have curvilinear motion. The rectilinear motion here is when an object moves in a straight path. But when an object moves in a curved path, that object is said to be in a curvilinear motion. Then the second one here is oscillatory, or you call it vibrational motion. Oscillatory, or you call it what? Vibrational motion. This is a repeated to and fro motion about a mean position. I said that is what? A repeated to and fro motion about a mean position. Example of this is the vibration of a turning fork. Then another one is the pendulum of a clock that will move to and fro. It moves. You have a pendulum of a clock here, and it moves to this direction and also to this direction. It keeps repeating the movement. So that is what is known as oscillatory motion. Then the next type of motion here is rotational motion. That is the motion of an object about a fixed axis. Example of this is the rotation of fan blades. It rotates about a fixed axis, and also the rotation of a bicycle wheel. That is example of rotational motion. Then the last type of motion here is known as random motion. In this kind of motion, the object moves in irregular shape. It moves in it does not have a specific direction. Let me put it that way. The object does not move in a specific direction. Example of this is the movement of gas molecules. Gas molecules, when you open your gas, you see the way they move. The molecules move in they will not move in a particular direction. That is example of what of random motion. All right, in the study of motion, there are other things to consider, because we defined motion as the change in position of an object with time. So when there is a change in position, that means an object moves in what? In a distance, covers a particular distance. So we are going to consider what? Distance and displacement. All right, when you talk of distance, you are talking of a total distance or a total length an object cover. A total length an object cover. Understand? So if maybe an object is at this position, we call it this point A, and the object moves from point A now to point B. Here, let's assume that this from here to here is like 100 meters. So the object that is said to have covered a distance of what? 100 meters. So that is the total length that this object cover. Now the distance is measured. Since we are talking of length, in our previous lesson, I told us that length is measured in what? In meter. So the unit of distance is in meter. Now, since the distance here we are talking about is talking about what? The total length covered by an object. So here the unit is in meter. Now, what is displacement? Displacement simply means the shortest distance. When you are talking of displacement, you are talking of the shortest distance an object cover. For instance, let's look at this. Now we have a point here, point A here, and an object moves from this point A to point B, and return. Let's assume that from point A to point B here is 90 meters. Now the object moved from point A to point B and cover the distance of what? 90 meters, and return to a point here. Then from here to here is 50 meters. Now you look at this. If you want to calculate the total distance covered by this object, you will now say that this object moves from here to here and cover a distance of 90 meters and return and also cover a distance of what? 50 meters. When you add 50 and 90, that will give you 140 meters. That is the total distance covered by this object. But when you are talking of displacement, you are talking of the shortest distance. Since the object moves from this point to this point and return to this point, it means that the displacement here is 90 minus 40, so minus 50 rather, and the displacement here is what? 40 meters. Both distance and displacement, they are both measured in meters. Now, okay, now distance now is always positive. It has a positive value. For instance, here, maybe you say a man covers a distance of 20 meters. That 20 is not minus 20, is a positive value. Now, but displacement here can be 0. For instance, let's still look at this diagram on the board here as an object. Okay, that we said that an object moves from a point A to point B. This is the distance of 90 meters. So if the object, maybe let's assume that it's a man. The man moves from here to this point and the distance is 90 meters, and the man returns to the same point A, and the man has covered another 90 meters. If you are talking of distance here, you are talking of 90 plus 90, which is 180 meters. But if you are talking of displacement, because 90 minus 90, the man has gone back to that same point, displacement is 0. Because if you subtract 90 from 90, you have what? 0. That's why I said that displacement can be 0. I believe you understand. So the next thing we are going to look at is speed. We are going to look at speed. We are going to look at speed. Then we are also going to look at velocity. When you talk of speed, what is the meaning of speed? What do you really understand by speed? What is speed? You can simply put that speed is the change in distance of an object with time, or you say speed is the change in distance with time, or change in distance of an object with time. For instance, you have an object to move here, and when the object move from here to here, you divide the distance that object covers with time it takes the object to move from this point to this point. That gives you the speed. So here speed is equal to distance all over time. So speed is equal to distance all over time. Now this speed is measured in what? Meters per second. I told you that if you understand the basic units of each of these quantities, that it will be very easy for you to understand the unit of a particular quantity you are talking about, because we have the fundamental unit and we also have the derived unit. Now distance, I told you that is measured in meter and time is measured in seconds. So the unit of speed here is what? Meters per second. And remember that speed is a scalar quantity. Likewise, distance is also a scalar quantity, but displacement is a vector quantity. When we get to scalar quantities and vector quantities, I will explain it better so that you should be able to differentiate those quantities that are scalars and those that are vectors. Alright, I said that speed is what? Is a scalar quantity because it has only what? Magnitude. It does not have direction. But when you talk of velocity, when you talk of velocity is simply equal to what? Displacement all over time. Displacement all over time. So here it means that the unit of displacement, I told you displacement is measured in what? In meter, and time is measured in seconds. So the unit is what? Also meters per second. The difference between velocity and speed is that speed is a scalar quantity. It has only magnitude, but velocity is what? It's a vector quantity. Velocity has both magnitude and direction. Alright, and the unit is what? Meters per second. Remember that we have uniform velocity. We also have a non-uniform velocity. Alright, the next thing we are going to look at is what? Acceleration. We are going to look at acceleration. What is acceleration? Acceleration simply means the rate of change of velocity. The rate of change of velocity with time. When you talk of acceleration, you are talking of what? The rate of change of velocity with time. So it's simply equal to what? Change in velocity all over what? Time. Change in velocity all over time. When an object accelerates, it means that that object was moving with in a particular speed, but suddenly the object decided to do what? To change the speed, maybe increases the speed. So now the acceleration there is change in velocity all over time. That means change in velocity here simply is equal to, we have v here for final velocity minus the initial velocity, which is the velocity that that object was moving with before, all over time. That is what? That is acceleration. So here, if you look at here, we have here change in velocity all over what? All over time. And you know that velocity is measured in what? Meters per second. Now, for you to know the unit of acceleration, since you know that it's change in velocity all over time, and you have the unit of velocity here, but there is time here, you now say, oh, this is all over what? You can put, let me write it this way, divided by second again. So this is the same thing as what? M all over S times 1 all over S, because this is just like saying over 1 here. So, you know, when you change the division sign to multiplication, then the denominator will come up to be the numerator, and the numerator will come down to be the denominator. So that is equal to meters per, you can write it this way, meter per second square. If you can as well write it as what? Meters per second square. That is the unit of acceleration. Remember, we have uniform acceleration, we also have non-uniform acceleration, and we also have what is known as what? Retardation. Retardation simply means negative acceleration. Retardation is what? Negative acceleration. So we are going to look at 3 equations of motion. 3 equations of motion. Now here at this, the 3 equations of motion, we have the first equation of motion as V is equal to U plus AT. So if you look at this equation very well now, V is equal to what? U plus AT. Here you have the final velocity, you have the initial velocity, you have the acceleration, and you have the what? The time. So if when you are to use, when you are to use this equation when you know the initial velocity is given to you, at times is always 0, because at times if a body is at rest and the body starts moving, so that means that the initial velocity is what? Is 0. Then you have the acceleration and time. You make use of this what? First equation. We call it first equation of motion. Then the second equation of motion is what? S is equal to, you have here ut plus half at squared. Now if you look at this, you have S here stands for what? The distance. S here stands for the distance. Then you have the initial velocity here, you have the time here, then you have acceleration and time square. So here, when you have distance, you have the initial velocity and time, then acceleration, you make use of this second equation. You call it second equation of motion. Then here you notice that this one explains the relation between distance, time, and what? Acceleration. There's nothing like a what? Final velocity. Then the third equation of motion says that v square is equal to u square plus 2as. So here you see that there is no time in this state equation of what? Motion. In this state equation now, let me call this what? Second equation. Second equation. Now look at this state equation here. Here, what you have here is the final velocity, the initial velocity, the distance, and what? Acceleration. There is no time. So you know when to use this equation. So if you know when you have a problem to solve that there is no time, you can make use of this third, you call it third equation. Third equation. All right. Before we proceed, we are going to, let's take one example. Let's take one or two examples. Let me check. I think we have. Okay, let's take this example. Okay, example 1. Call it example 1. EG1 here. Okay, a car travels 100 meters in 5 seconds. A car travels 100 meters in 5 seconds. Right? Full stop. Then the question is find its speed. Find its speed. Find its speed. A car travels 100 meters in 5 seconds. Find its speed. All right, so if you look at this, you check, okay, solution. Let's see. I told you before you solve any problem, you need to understand the unit. No, understand the unit. Then if you understand the unit, you will know exactly what to do. So here we have here 100 meters per second. You should think, what is that thing as measured in meters per second? You know, that is what? Distance. You can use s for distance, then use x for what? For displacement. You can use s for distance, then use x rather for displacement. All right, so here we are asked to find the speed. Now write that speed is equal to distance all over time. Speed is equal to distance all over time. Now you have distance is equal to 100 meters. Then time is equal to 5 seconds. Then speed, you don't know. Speed is what you are looking for. Speed is unknown. You have to find the speed. This is very simple. Hence, you know the formula. You've written the formula already. So you just come here and substitute these values and get your answer. So you come here and say distance is 100. You now write here. Let me divide the board by 2. So now write here that speed is equal to distance is 100 meters. 100 all over time is 5 seconds. 5. Now 5 cancel itself. 1 cancel 100 20 times. That is equal to 20 meters per second. 20 meters per second. Very simple. That is the answer. That is the answer. Look at it again so that you understand better. All right, we are going to take another example. And we call it example 2. We are going to take another example. We call it example 2. We are going to take another example. Example 2. Let me take the question. Example 2 here says that a body starts from rest and accelerates at 2 meters per second square. A body, example 2, a body starts at rest and accelerates at 2 meters per second square for 10 seconds. Full stop. Find its final velocity. Find its final velocity. Find its final velocity. So if you look at this, see the parameters you have here. You have 2 meters per second square. That is acceleration. A. Let me write it. Solution A is equal to 2 meters per second square. Then and you are told that the body starts at rest. That means there is an initial velocity. There is an initial velocity u. So here u is equal to 0 because I said that initial velocity can be 0 once the body starts at rest. The body is at rest, and soon the body starts to move. It means that the body has initial velocity of what? 0. That means u here is equal to what? 0. Now you are told that the body accelerates at 2 meters per second square for 10 seconds. So here t is equal to what? 10 seconds. Now you should look at, in this you have acceleration, you have initial velocity, and you have time. You should think of the formula. What am I going to use to get this? If you consider this, if you consider acceleration equal to change in velocity or you write that A is equal to what? V minus U all over T. You will not get it because there is no what? You don't have any what? You are even looking for what? Final what? Velocity. So what you should do is to look at, though if you cross multiply, you know the first equation of motion is gotten from here. So you can still get it. If you substitute these values now and bring this out, you can still get it. But since we've written the equation of motion, and now think of which of this equation of motion that has this what relationship. And now remember that we have the first one that it says that V is equal to U plus what? AT. We now come here and substitute these values here. That means V is equal to U here is 0. You write 0 plus, you have A as 2, A is 2, now multiply by, because here is multiply by 10 seconds, multiply by 10. So here V is equal to 0 plus 2 times 10 is 20 plus 20. V is equal to what? 20. What is the unit? Meters per second. Meters per second. So motion is very important. You need to understand this. And remember that there is something that causes what? Motion. A body, like if you drop this marker here, this marker will remain here. Will remain here until something happens. Something must happen before this marker will be in motion. That means there will be a force acting on it before this marker can start to move. That's going to be our next topic. We're going to see how force causes what? Motion. So what I should advise you is to follow this one after another. Make sure you understand everything. Then any way you don't understand, go to the comment section. Make sure you ask your question. Comment. Your comment is very important to us. So thank you.